It took long time to download. That's why this exercise will be discussed tomorrow. Let's begin the new topic. And for presentation, I want to call on the stage Ritika Maharjan. I think upper one.
And animations.
Animation also, so you have to download.
Namaskar everyone. As always, Ritika Maharjan. I'm here to I'm here to give some presentation on the chapter pressure.
Oh, far away. Yeah, thank you.
All the matters can give pressure. Pressure is the perpendicular force applied per unit area and on any surface. Thus, the P is equals to force upon area,
Area.
the amount of force applied over the total area of of a surface or the pressure on the entire surface known as thrust expressed as thrust P into A. Pressure plays an active role in various daily life events. Various units are used to express pressure. Some of these are derived from a unit of force divided by a unit of area. The SI unit of Pascal, the Pascal is the SI unit of pressure is the Pascal PA. For example, 1 Newton per square meter. Similarly, the pound force per square inch symbol is the relational unit of pressure in the imperial U.S. customary system. Pressure may also be expressed in terms of standard atmospheric pressure. The unit atmosphere is equal to this pressure, and the torr is defined as 1 by 760 of this manometric units such as the centimetric of water, millimetry of mercury, and inch of mercury are used to express in terms of the height of column of particular fluid in a manometer. As you all can see the picture of low pressure and high pressure. Transmission of pressure. You notice that area can be squeezed but water cannot. Why does this happen? It's because of the different nature and composition of air and water. Let's understand the process. Air has more space between its molecules. When you push the piston of string filled with air, the air molecules get closer together, reducing the space between them. This makes the piston move over a long distance, showing that air can be compressed. Water on the other hand has less space between its molecules. When you push the pistons of string P filled with water, the water molecule cannot squeeze closer due to the limit space B limit space between them. This result is the piston moving over a shorter distance, indicating that water cannot be compressed. If you compress air highly, it also can transmit the given pressure in all the directions equally as done by liquids. Likewise, Pascal's law. Pascal's law was made by a French scientist named Pascal in the year 1647. It's one of the basic idea in a part of physics called hydrostatics. Hydrostatics look at how fluid behave when they are moving. In bottle we used squeezing, it makes water blows through all the holes. According to Pascal's law, when you press on a liquid in a closed space, the pressure spreads out equally in all directions.
The next.
Wells Pascal. Wells Pascal was born.
Biography.
Wells Pascal was born on June 19, 1623, Saint-Germain, France died in August 1962. Paris was French mathematics, physics, religion, philosopher, and master of arts. He laid the foundation for the modern theory of probabilities, formulate what came to be known as Pascal's principle of pressure, and propagated a religion doctrine that taught the experience of the God through the heart rather than through reason. The establishment of this principle of institution had an impact on such later philosophers and James Rogers and Henry Bergson, and also on the existential use of empty plastic water bottles. Experimental verification of Pascal's law. To verify Pascal's law, spherical vessels filled with water and filled with leak-proof identical piston ABC, and D is taken when piston A is pushed inward with force F. The pressure exerted by piston P is force upon pressure, where P is the area of the piston. This pressure is transmitted throughout the liquid and act at right angle to the surface of all the other piston. As a result, the pressure causes the other piston, that is B, C, and D, to push outward equally. This experiment proved that liquid pressure is transmitted equally in all the direction by the liquid enclosed in a vessel. Pascal's law is also known as the principle of transformation of fluid pressure. Application of Pascal's law. Pascal's law tells that if pressure in an enclosed liquid is changed at any point, there will be equal change in the pressure at the other point in the liquid. This fact is used in hydraulic machines such as hydraulic pressure, hydraulic brakes, hydraulic garage lift, hydraulic canes, etc. Pictures of some hydraulic machines. Hydraulic pressure, hydraulic brakes, hydraulic garage lift, hydraulic cranes. Thank you.
Super good. Listen.
So namaskar everyone. So I'm going to discuss about the chapter pressure, which is made by Ritika. So here is saying all matters can give pressure. Pressure is the perpendicular force applied per unit area on any surface, that is P equals to force by area. And there is example also. The SI unit of pressure, the Pascal, for example, is 1 Newton per square meter, and similarly the pound force per square inch. PSI symbol. This is the traditional unit of pressure in the employed and US customary systems. So this is the picture of low pressure and high pressure, transmission of pressure. So here is the example of one sink. So you can see there, this is filled with water and this is filled with chalk powder. So water molecules are less space between them, so they cannot be compressed using these pistons. But in chalk powder, they are compressible, and this is air. So air molecules have more space in them, so they can be compressed, like you can see in this figure. So You notice that air can be squeezed, but water cannot because water have less molecules and less space between the molecules, and air has more space between them. So water, on the other hand, has less space between these molecules. When you push the pistons of syringe B filled with water, the water molecules cannot be squeezed closer to the limited space between them. Pascal's law. Pascal's law was made by a French scientist named Blaise Pascal in the year 1647. It's one of the basic idea in the part of physics called hydrostatics. Hydrostatic looks at how fluids behave when they are moving. In the bottle, so in the bottle wheel, squeezing it makes the water flow. Like suppose this is one bottle, and if you make some small holes in it and press this, then water can be flow very fast. So yeah, this is writing about this. Bio of Blaise Pascal. Blaise Pascal was born on June 19, 1623, Clermont-Ferrand, France. Died August 19, 1662. Was a French mathematician, physician, religious philosopher, and master of prose. He laid the foundation for the modern theory of probabilities, formulated what came to be known as Pascal's principle of pressure, and propagated an religious doctrine that taught the experiment of God through the heart rather than through reasons. So here is the example of use of empty plastic bottles. Experiment verifications of Pascal law. To verify Pascal law, a spherical vessel is filled with water and filled with leak-proof identical pressure A, B, and C, D. You can see in this figure. So, when a piston A is pushed inward with force, F, the pressure exerted by piston is F by P, where P is the area of the piston, and this pressure is transferred throughout the liquids and acts as right angle to the surface of all the other pistons. Next one, this experiment proved that liquid pressure is transferred equally in all directions by the liquid enclosed in a vessel. Pascal law is also known as the principle of transformation of fluid pressure. Application of Pascal law. Pascal law tells us that if the pressure in an enclosed liquid is changed at any points, there will be equal change in the pressure at the other points in the liquid. This fact is used in hydraulic machines such as hydraulic press, hydraulic brakes, hydrogen gas lift. Pictures of some hydraulic machines. Hydraulic press, hydraulic brakes, gas lift. Thank you.
Yes, thank you very much. So, I think today flower also, right? Oh, thank you. It's given. It comes here, right? We can do like this. Here, mainly we have to remember what is pressure. What is pressure, children? Pressure is force acting per unit area. Simply, this is the one. Pressure equals to force acting per unit area. So, what is the SI unit of pressure? SI unit of pressure is Newton by per meter square, and m minus 2, or to honor Blaise Pascal, they have written PA, either Newton per meter square or Pascal, right? Other units are also there. So other units are there. This I'll show you. What are the other units of Pascal? Sorry, pressure. Other units of pressure are, see, one is Pascal. Yes or no? Here we have to remember force acting per unit area is pressure. SI units are Pascal or Newton per square meter, or
Pound force.
what is here?
Pound force
Pound.
per meter inch is
Pound force per square inch, PSI. Next one, what is here? At ATM, it can be written ATM also. Okay, or torr, TORR, torr. or centimeter of water, millimeter of mercury, or inch of mercury. Like, what is the atmospheric pressure at sea level? Do you know? What is the value of atmospheric pressure at sea level? They write 760 mm of Hg, not mg, Hg. 760 mm of Hg. So it is expressed like this also. But if in you have to express in Pascal, then that is 1.01 times 10 to the power 5 Pascal. 1.01 times 10 to the power 5 Pascal. So different units are there, right? Next one. Next one, we have to remember about this one. This, can you see? Here is given low pressure. Here is given high pressure. It is compare. No. Why here is low pressure? Large area. Why is here less pressure?
Because
Small
the
area.
area is
One thing you have to keep in mind. Once again, what is the relation between pressure with its factors? Pressure is directly proportional to force. Pressure is directly proportional to force.
but
And pressure is inversely proportional to area. That's right. So I've got here this palm, right? So if I hit this boy in this way, this is one, there is one area, right?
Yes.
And some force is applied this way and another this way. In which case you will get more pressure. This one. Why? Because it occupies less area. Less area, more pressure. More area, less pressure. Here also, area is large, pressure is less. Here area is less, pressure is more. An elephant exerts more pressure on the ground or the pencil heel of a girl. Which one exerts more pressure on the ground?
more pressure.
Yeah, more pressure. Pencil heel of the girl or
Pencils.
pencil heel, because area is very
Yes,
less. You might have noticed
Yes.
when there is any need of fixing that nail, we just keep that pointed part towards that wall or that flat part,
Pointed part.
pointed towards that side, because
Because
area is less,
and it
pressure is more. You have to remember. Yes or no? So this is the relation. Pressure is directly proportional to force, inversely proportional to area. So larger area, less force; smaller area, more force. Um, this is smart board pen, right? So this portion exerts more pressure, or this portion? This one or this one? This one? Why?
Because highest area.
Less area, more pressure. Right? So this thing also you have to remember. And here is given transmission of pressure. Can pressure transmit or not? So here are three devices. This long structure is called piston. What do you call it? Piston. This is syringe. And what is kept here? Chalk powder. Chalk powder is solid. What is this? When we try to press it, it doesn't go down because it is incompressible. It cannot be compressed. But what is kept here? So water, I think water can be compressed little bit. Here we have to remember Intermolecular. What is study? Intermolecular space. What do you mean by intermolecular space? Space between molecules, two molecules. Like if there are three containers, how many containers are here? Okay. Okay, suppose these are the molecules of solids, liquid, and gases. Now tell me, what is this? What is this? What is this? This is molecule of gas, right? Why? There is more space between molecules. What is this? Liquid. Why? There is less space between molecules. What is this? Solid. If we try to compress, can you compress? Because there is very less space, no? You might have noticed. Do you travel in public transport or not?
Yes.
So traveling in public transport, while going from here to Chennai, the Khalasida says, Bitra jao, Bitra jao, Bitra jao.
Yes. Yes.
Yes or no? One is pressing from back, also front also. Is that like solid compressing, right? But if that is train, right? Metro train. I think you haven't traveled through metro train
Yes.
in India. In Delhi, I got chance. Just very easy. Just go. People just going slowly. Yes sir. And if you have just reserved bus, is there more crowd or less crowd?
Yes.
Very less.
Because
It's just like that. Reserved bus, like gas. That metro train, like liquid. And that,
solid transport.
yeah, this
Vehicles.
public transport with those coachify, which I say coaching here to there, just like so. That means solids cannot be compressed. Liquid can be compressed little bit, but gas can be compressed more. Because of that, you can feel gas inside the football or basketball.
Yes.
Yes or no? Why? Gas particles remain far away. When you compress, they come quite closer. Right? This is the thing here. So, because of a little bit compressing property of liquid, it can be injected in our blood stream also. Right? Injections can be given or not? Yes, that is all. And Pascal's law we need to remember. What do you remember? Pascal's law. So, when did Pascal's law propound?
1647.
1647. How old was he at the time?
That France science.
He was born in 23. 47 means at the age of 24. He just gave this one. Right? So, it's given here Pascal's law. Pascal's law is not given here. Only about his biography, right? When he was born, when he was dead, and Pascal's activities was means everything over here. And he was the person to give Pascaline also. Pascaline, one counting device, right?
Pascal, yes.
Pascaline. And here we can see this is the water bottle, and when we make holes from the base, liquid comes with more pressure, from upper it comes with less pressure. Water pressure. But when we make it tight, when we make this portion tight and make more holes here and press it from one side, apply some force, then what will happen? From each hole, it comes with equal pressure. So, what is given there? Pascal's law. Will you check there? When pressure is applied in a.
When pressure, yes.
Okay, everybody, please read that one first and underline this.
So when you press on a liquid in a
Closed container.
space, the pressure is split out equally in all directions.
Yeah. When
you press a liquid in a closed space,
Close with the
the
pressure
pressure
spread
is
out
split out
equally
equally in all directions.
or very similar, we can say liquid exerts pressure equally in all direction. Liquid exerts pressure equally in all direction. One diagram is given here. Such type of vessel is here. And what is fitted in this vessel? Piston. What do you call it? Piston. This is one piston. You can move inside, outside, inside, outside. Here is also piston. Have you seen piston or not?
Yes.
Piston means that in syringe, when you pull it, piston comes towards us, you can go inside also, like that. The piston also can move inward and outward. Inward and outward. Take like this vessel, and this vessel must be fitted with simply what to do? Water. Water is easily available, right? After fitting, what is kept here? Piston. How many pistons are fitted? Oh, piston A, B, C, D. 4 pistons are here, and the liquid is filled very tightly. There should not be air. there should be liquid only. When piston A is moved inward or pushed inward, then what will happen? It exerts pressure. What does it exert? That pressure transmits equally. As a result, piston B goes outside, piston C goes outside, piston D also
Yes.
goes. One goes inside,
Next
three comes outside.
in equal. Yes.
Yeah, isn't it? So because liquid transmits pressure equally. Next thing, if it exerts 200 Pascal, how much pressure?
200 Pascal.
So this also comes out with how much Pascal?
200 Pascal.
Is also
200 Pascal.
200 Pascal. This also 200 Pascal. That's why you just remember what does Pascal's law state?
Pascal states that
Liquids exert pressure
in every
equally
in all directions.
in all directions. Simply remember, what is given here? Liquids exert pressure equally in all directions. So Pascal's law. And the last one is application of.
Pascal law.
Here is given Pascal's law. She has given here Pascal's law. What is here? If pressure in an enclosed liquid is changed at any point, there will be equal change in the pressure.
Other point.
That is the one, right? And what are the devices based on liquid pressure?
Sir,
Which devices are based? Hydraulic press, hydraulic brakes. Look at here. The different devices based on it are hydraulic press, hydraulic brakes, hydraulic garage lift, hydraulic crane, etc. Hydraulic means what is used there?
There is here water.
Water. Water is incompressible. They press water in one side and the body moves another side. Like truck, car, or let's say 4-wheelers or 10-wheelers, 20-wheelers, whatever devices are there, what is used? Pascal's law is used. The hydraulic brakes are used. Now diagrams, let's see. So what is this? Hydraulic press. This device can move down and up, right? And press it. We say plywood. What do you call? Plywood. How is plywood made? Plywood is made by pressing the sawdust. Oh my God, what is sawdust? Sawdust means dust of wood. When they cut the wood, dust comes out or not?
Yes.
That is pressed and what is made? Plywood. What is next one? Hydraulic brakes. It is used in car, bus, etc. Not in motorbike. In motorbike they use disc brake, right?
Yes. Yes, ma'am.
See, here, oh, you can see here. Here is brake. Can you see a brake or not? Here is a brake. When they press this brake, the liquid present here, it just moves slowly and presses it and stop the wheel. No need to go and catch it. Simply you press and this one presses, this also presses, liquid transmits and stop the work. What is this?
This is hydraulic.
Hydraulic garage lift. Next one, hydraulic crane. So means they all are based on Pascal's law. They all are based on Pascal's law. So in today's class we discussed about definition of pressure, factors affecting pressure, and next thing I forgot to tell you, how do you define 1 Pascal pressure? 1 Pascal pressure is 1 Newton by. So what is the definition?
1 Pascal is the one.
The pressure exerted by unit force on unit area. Let me write here. What is there? The pressure applied or exerted, you can write. Exerted by what? Unit force. Unit force means 1 Newton force.
Yes.
Unit force on unit, what is that? Area is called, what do you call it?
1 Pascal.
1 Pascal pressure. And if you write that one, you will get full marks. Okay? So children, one thing what you have to do, focus on study. Mainly what to do? Focus on study. And when you are reading, just go deeply in that paragraph or writings. Don't think other things. Then you can understand the thing. Looking at the book, our mind is roaming here and there, thinking about free fire and cricket, football, Germany between Germany against Hungary, France became France against Austria, like that. If you think, then maths also comes like that. To get double digit math difficult. Now study has become quite difficult. In our time, pass percentage was 32%. It means we must deserve minimum 32 marks to pass. But now you have to deserve how much? 35 marks. 35% I mean, not marks, 35%. Like in theory, you must deserve minimum 27 marks. Otherwise, you are failed. In practical, 40%. Practical, no problem. That is your internal matter. You can do well, you will pass. But theory, you must deserve better marks. And you study in smart school. Deserving just pass mark doesn't matter. Minimum 3.60. Your GPS will be how much? 3.6. Accordingly, you practice. So that you can understand and do your work independently. That's why I always remind you, great people, they don't do different things. They do the things different way, differently. That's why you are the product of Anupam. Do your best and make your career. Thank you. And you